Hi, fifth graders. Welcome to lesson 11.5. This lesson can be found on textbook page 663. The title of this lesson is Unit Cubes and Solid Figures. The standard we are using today is in Measurement and Data 5.3. This standard states, I can recognize volume as an attribute of solid figures and understand concepts of volume measurement. So we are going to be talking about our unit cubes today and how we first start to understand volume. Our essential question is asking what is a unit cube and how can you use it to build a solid figure. So under our investigation, we are going to learn what a unit cube is and how to identify our volume. So you can build a rectangular prism using unit cubes. How many different rectangular prisms can you build with a given number of unit cubes? So we are going to find that answer out in our investigation. So in order to understand how to solve this, we need to make sure we understand what a unit cube is. So a unit cube is a cube that has a length, a width, and a height of 1 unit. So we have a length of 1, a width of 1, and a height of 1. So the length is how far across it goes, the width is how far back it goes, and the height is how tall it is. So our unit cube is always a 1 by 1 by 1. Now, if you recall from lesson 11.4, a cube is also a rectangular prism, and a cube does have square faces. Now we do need to figure out how many square faces it has. So all cubes have a top and a bottom. So you would have one top face, one bottom face. So if I actually finish drawing this, we do have a top and then a bottom, and then you have a side, and then you have your front and back. So that would count as 6 square faces. Top, bottom, side, and front, back. Now, all of the faces have to be congruent because remember, it is a square face, and all squares for our cube must be congruent. Now we need to count the number of edges this cube has. So I see on the top face, there are 4 edges. Then on the bottom face, there are also 4 edges. And then the sides, you again have 4 edges to complete. So I have a total of 12 edges with this cube. Now we're going to start our investigation. We're first going to start with a prism that has only 2 unit cubes. So I did shrink that unit cube down so that way I can build this prism with 2 unit cubes. So with this prism, notice they're asking how many faces does it have. Well, just like before, I've now placed both of those cubes together. I still have the front face, which means it would have the back face. So there's 2. Then you have the top face, which then you would also have the bottom. So that's another 2, so that's 4. And then you would have both side faces. So that would be another 2 faces. So there would be 6 faces total in this rectangular prism. Now to count the number of edges, it's just like my 1 unit cube. I'm still counting the final edges. So on the top I have 1, 2, 3, 4. Means the bottom would also have 4, so that's 8. And then for the sides I have 9, 10, and then the other side would be 11, 12. So it still has 12 edges. Didn't matter that I have 2 cubes. Those 2 cubes, when combined together, you're combining and creating one large face. So now for B, they want us to build as many different rectangular prisms that we can with 8 of those unit cubes. So if I want to have a rectangular prism that just has my 8 cubes that are stacked beside each other. So, pardon my picture, but that's the best I could do with having the visual. Notice I do have 8 unit cubes going across. Oops. So my length of my prism is 8 units across. Now my width, I see that it is only going 1 back. So my dimension for that width would be 1. And then my height, it's only 1 cube up. So my height would be 1. So my first dimension that I've created is an 8 by 1 by 1. Now obviously we could have had 1 by 8 by 1 or 1 by 1 by 8. It doesn't change it. It's just flipping the prism, either standing straight up or it's flipping it so that way it's going back. But mine is just going straight across. Now another way that I could create my prism, I could have 4 going across, and then I could stack 4 more on top of that. So now, notice my length is only 4 this time. My width is still only going 1 deep, but my height is now 2. So I've created a 4 by 1 by 2. Again, I could stand it straight up, so I would have 2 by 1 by 4, or I could flip it so that way it's going deep, and I could have a 1 by 2 by 4. So it doesn't matter the order of your dimensions. It would still be the exact same number of cubes, just flipping the prism around. And my final way that I could create a prism using 8 cubes so this might be a little difficult, pardon my picture. And then if I would place cubes directly in front, sorry, trying to make it so that way you can still see all 8 of my cubes. I now would have a rectangular prism where my length is 2, my width goes 2 deep, and my height is 2. So I still use 8 cubes, but I've created a prism that is 2 long, 2 wide, and 2 tall. There are no other ways that we could use 8 cubes to make another prism, because we would just be using the exact same numbers but just changing their order. So now, after this investigation, using 8 unit cubes, I see that there are 3 different prisms that I can create. Moving on to page 664, we're just going to talk about the different things that we've noticed with our investigation. So number 1, they want us to explain why a rectangular prism is composed of 2 unit cubes that has 6 faces. How do its dimensions compare to a unit cube? Well, if you remember from our investigation, we found that 1 unit cube had 6 faces and 6 edges. And then when we created those 2 unit cube prism, I still had only 6 faces and 12 edges. And ladies and gentlemen, that is because 1 face of a unit cube completely covers the face of the other unit cube, and both are on the inside of the prism. So the prism still only has 6 faces. You've just created a longer or bigger face. the rectangular prism has one dimension that is 2 units rather than 1 unit. Moving on to question number 2. Explain how the number of edges for the rectangular prism compares to the number of edges for the unit cube. Again, from our investigation, we found that they both had the same exact number of edges. And that is because the number of edges for the rectangular prism and the unit cube are the same. You created one longer face, so therefore you created a longer edge. So you still have your 12 edges. And for number 3, describe what all of the rectangular prisms you made in step B have in common. So that is when we had our 8 unit cubes, and then we recorded that in step C. So the rectangular prisms that I made in step B are all built with the same number of unit cubes, and obviously that was 8 cubes. Now under the Make Connections, this says you can build other solid figures and compare the solid figures by counting the number of unit cubes. So not all of our solid figures are always rectangular prisms. In order to find those basic solid figures, you can just count the number of unit cubes, and that would give you your volume. So for the picture on the left, figure 1, I see that it is created by making 6 cubes together. So figure 1 is made up of 6 unit cubes. Figure 2, the green figure, notice if you count it all out, it is made up of only 5 unit cubes. So if I would want to compare these, I would say that figure 1 has more unit cubes than figure 2. Now for this bullet point, it does have us using 12 unit cubes to build a solid figure that is not a rectangular prism. They would ask you to then share your model and then describe how your model is the same and how it is different from your partner's model. Well, obviously, you are not going to have those unit cubes to create your models, but you should make sure that you understand that as long as you have 12 unit cubes, your volume would still be using those 12 cubes. So your volume would still be your 12 with your unit cubes. And that your pictures would still be similar because you have the same number of cubes. Now on the next page, your share and show questions. This is very similar to what you are going to be doing on your homework. Number 1, it says the rectangular prism is made up of blank unit cubes. Well, we're just going to be counting. We have 1, 2, 3 total unit cubes that were put together. So it is made up of 3 unit cubes. Remember, all unit cubes are 1 by 1 by 1, so therefore we would have 3 unit cubes. For number 2, I see that there are 1, 2, 3, 4, and then I could continue counting, or I would say that they're going up, we would also have 3 going up. So I can take 4 times 3, which does equal 12. Notice that the back is only 1 deep, so there are only 12 unit cubes. For number 3, I see that there are 6 unit cubes on the front, but I also see that it goes 2 deep, so that means there would be 6 on the back. So 6 plus 6, or 6 times 2, is 12 unit cubes. Number 4 is one we definitely want to make sure we are counting. So I have 1, 2, 3, 4, 5, 6, 7. So there are 7 unit cubes for number 4. And then for number 5, they want to know, how are the rectangular prisms in exercises 2 and 3 related? So we're looking at questions 2 and 3. They want to know how they are the same. Then they want to know how can you show a different rectangular prism with the same relationship. So for this, I see that both rectangular prisms were built with the same number of unit cubes, which was 12. So they both have 12 unit cubes. I could show a different rectangular prism using 12 cubes by having 6 cubes long, 2 cubes deep, and 1 cube high. You also have a couple of questions on your homework that are similar to 6 and 7. Obviously, we have to count the number of cubes in each of the figures, and then we will use the signs less than, greater than, or equal to. So for number 6, I have turn my pen back on. 1, 2, 3, 4, 5, so 5 unit cubes. And then on the right, I have 1, 2, 3, 4, 5. So I also have 5 unit cubes on the right figure. So obviously those two figures would be equal to each other with the same number of unit cubes. For number 7, 1, 2, 3, 4 unit cubes on the left. And then on the right, 1, 2, 3, 4, 5. I have 5 unit cubes on the right, so when I compare them, 4 is less than 5. For question number 8, it says Melissa makes a solid figure by stacking 1 cube on top of a row of 2 cubes on top of a row of 3 cubes. Then she rearranges the cubes to form a rectangular prism. Describe the arrangement of cubes in the rectangular prism. So if she is rearranging these cubes, we would now have 1 row of 6 cubes, because notice she has 1 on top, then 2 cubes, and then 3 cubes, so that would give you a total of 6 cubes. Or you could rearrange it again. This time you could have 2 rows, and each row could have 3 cubes. Moving on, I am going to go down to the blue box. Question number 11. You have a test question that will be very similar to this. It says match the figure with the number of unit cubes that would be needed to build each figure. Not every number of unit cubes will be used. So again, the easiest way is we can count it. So on the top figure, we have 1, 2, 3, 4, 5, 6 on the front. Obviously it is showing that it would be also 6 in the back. So you would have 6 times 2, or 6 plus 6, and that gives you 12 unit cubes. So you could have solved 6 times 2, or 6 plus 6 to answer that one. Notice this next one, we are going to have to count. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 unit cubes. And on the bottom, notice I do have, looks like I have 3 in the front. It goes 2 deep. So that would be 6 total cubes on the bottom. Then I have this top section right here, only 3. So if I have 6 on the bottom, and then I have 3 more on top, 6 plus 3 would equal 9. So I have 9 unit cubes. Now for your homework, you will be solving 2 through 10. They will be fill in the blank for 2 through 7. And then, 2 through 6 are fill in the blank. Then numbers 7 and 8 are going to be both drop-down boxes. Select the correct number of unit cubes, and then also select the correct comparison sign. For number 9, this is a multiple choice question. It is going to be a mark all that apply, so there will be more than one answer. So your carton can hold 1,000 unit cubes that measure 1 inch by 1 inch by 1 inch. Describe the dimensions of the carton using unit cubes. Remember, for your selections that you mark, when you multiply the length, the width, and the height together, it should equal 1,000 unit cubes. For number 10, it does say draw and label all the rectangular prisms built with 16 unit cubes. You're not going to have to draw them, but just like how we did under the investigation part C, where we listed our dimensions for 8 unit cubes, you're going to do the same thing for 16 unit cubes. Think of the 3 numbers that when multiplied together equal 16. And then you will tell me how many rectangular prisms you've made. And that will be a fill in the blank. On the back, number 1, they want to know how many blocks she is stacked, so you're just telling me how many unit cubes she's used. That is a fill in the blank. Number 2 is just like number 10 on the front. Quentin has 18 unit cubes. They want to know how many different rectangular prisms can he build if he uses all of the cubes. So you're going to have to list all the different ways that when you multiply 3 numbers together, it would equal 18 for this one. So come up with as many ways. Remember, if you've already used that, for example, if I've already used 1 times 1 times 18, I can't switch the numbers around and use 18 times 1 times 1 and count that as another way. That would just be using the exact same numbers, and I've already used that way. For number 3, this is a multiple choice question. In what shape are the lateral faces of a pyramid? So if you need to help remind yourself what a lateral face is, that is from lesson 11.4. And remember, the lateral faces are what form, that connect up at the top to form your vertex. Number 4, the Arnold family arrived at the beach at 10:30 a.m. They spent 3 3/4 hours there. What time did they leave the beach? So I would, from 10:30 a.m., count up 3 hours. And then, after I've counted up 3 hours, I need to remember that 3/4 of an hour equals 45 minutes. So I need to add on 45 minutes. Number 5, this will be a drop-down box on Schoology. It says the opposite sides of a parallelogram are always, sometimes, or never congruent. And finally, number 6, the tire on Frank's bike moves 75 inches in 1 rotation. How many rotations will the tire have made after Frank rides 50 feet? So first of all, we should probably convert that 50 feet into inches in order to solve this. So if I'm converting from feet to inches, I am going from horse to fly, because obviously a foot is bigger than an inch. And I also know that 1 foot equals 12 inches. So I am going to make sure that when I do horse to fly, I multiply 50 times 12. Now, once I have that answer, I know how many total inches 50 feet would equal. Then I have to remember that there are 75 inches in 1 tire rotation. So if my tire, like this, if I'm starting up here, they are saying in order to go all the way back around to that same exact spot, it's 75 total inches. So now, in order to figure out how many rotations it would take that tire to go 50 feet, you would take the answer to this multiplication problem, and you are going to divide it by your 75 inches. If you have any questions on this, please let us know so that way we can help make sure we explain anything further. Thanks.